Alright, welcome. So in this video we're going to take a look at special triangles and evaluating different ratios at various places around the unit circle. So the first one we're doing is sine of 210 degrees. We're going to draw it from standard position, takes us into quadrant 3, and we recognize that there's a 30-degree reference angle between the x-axis at 180 and the terminal arm. Looking at the ratios, you can see y is -1, the radius is 2. Our ratio at 210 degrees for sine is -1/2. Second, when we look at a cosine, we'll go to a different quadrant. We'll do 315 degrees. So again, we ask ourselves, okay, we know in quadrant 4 from our cast diagram that we've gone over before, we're in quadrant 4 where cosine is positive. Now, 315 degrees has a reference angle of 45 degrees, so we know we're dealing with the other special triangle, 1/√2, and in this case we end up with x over r for cosine, which in our triangle is 1 over the square root of 2. And that cast diagram that I mentioned before, you can always check it. It basically comes from the signs of x and y. Positive x is pointing to the right in this case, which is why we have a positive value for cosine in quadrant 4. Now we'll try one with tan. This time we'll do, let's say, tan of 120 degrees. So we're in quadrant 2. If we go to our diagram, we know that tan is going to be negative there because only sine is positive in quadrant 2. And again, we look at our triangle. It's still the 30, 60, 90 triangle, but this time 60 is our reference angle because 180 minus 120 is 60. And we place our ratios into the triangle. Y over x in this case is √3/1. Now notice the x is negative because it's pointing to the left. Alright, now we're going to try a different skill. This time we're trying to find the angle given the ratio. And take a note that usually in grade 11 the domain restriction will be from 0 to 360, but not including 360 itself. So, for example, if they give you the ratio √3/2, on a calculator you could do second sine or arc sine, but we're going to try this without a calculator. Okay? Now we can do this by piecing together what we know about special triangles and quadrants in the unit circle. In this case, we see that our quadrants for sine, we know should be quadrants 1 or 2, which is where sine is positive. The reason that is that sine is defined by y, and y is positive in the first two quadrants because it's pointing upwards. So we look to the triangle that has √3 and 2. It's the 30, 60, 90 triangle again. We get a reference angle of 60, which is one answer, and a reference angle of 60 in the second quadrant gives us a larger principal angle of 180 minus 60, which is 120. So our two answers for theta are 60 degrees and 120 degrees. And make a note that your calculator might only give you one answer, so you do have to be aware that there's actually two answers to this question, and you don't need your calculator to find either of them, really. Alright, so we're going to clear this space up. We'll try another similar type of question. This time we'll do cosine. Theta equals -1/2. So right away, we can tell that we've got an x and we've got an r, and we know that cosine's negative in quadrants 2 and 3 because that's where x is negative. In our case, we know x is -1, and again, we're dealing with the 30, 60, 90 triangle, reference angle of 60, so we get similar answer to before, 120 degrees, but we also have to keep the circle going down into quadrant 3 to get a second answer of 240. That's 180 plus 60 is 240. Now for the last one here, we'll do tan. So let's say they asked you to figure out at what angles is tan theta undefined. Now, you can do this a few different ways. We know that tan is defined by y over x. To be undefined, you want to have x equal to 0, so you're dividing by 0. This happens on the y-axis. can tell you're at 0, 1, or when you point down, you're at 0, -1. So the 2 degrees associated with this, or the 2 angle measures, are 90 degrees or 270 degrees. So we say at 90 or 270, tan is undefined, or it does not exist, which is what DNE stands for. Another way to think about it is anywhere where cosine 0, tan will be undefined. Now for another one here, we'll do where is sine theta equal to -1. And again, really what this is, it means that we've got y over r, which is -1 over 1, which actually means we've got no triangle in this case. It means we're just pointing straight down. We must be at 270 degrees. And note that we could do this by looking at a wave. The sine wave function, which is new to us, but it is helpful. If you've memorized it, you can see that at 270, we're sort of at the trough or the bottom of the wave, which represents -1. It's the low point. So we'll get into more of that later. That is the sine function. Like I said, it does come in handy, but it's not essential at this point. What is essential, just to wrap up, is to go through the definitions of sine, cosine, tan in terms of x, y, and r. So we've been using these throughout. Hopefully you commit these to memory, or at the very least you know how to find them from the unit circle. Alright, thanks for watching. Hope you found that helpful.